Kia ora, Year 12 and 13. This is a question from the 1973 scholarship calculus paper. It's a really nice example of two things, how much we need to be comfortable with implicit differentiation, and also how I can use my log rules again to simplify problems that look pretty awful. So here we're going to find dy by dx when this is true. And just from looking, you can see that you're not feeling that great about it because you've got x to the power of something with y, and then y here and x here. Now you're given two other pieces of information that are going to help us a lot. And the first is that x is strictly positive and y is strictly positive. So that turns out to help, because one way that I can make this a little bit easier is to work some logs in here. I think you can do this in several ways. If you're really confident, you can just get into it with implicit differentiation, but the chances that you screw up with it written in its current form are quite high. And that's because here you're going to have to think about, what am I doing, what's my variable, and what am I holding constant? So it's easier, at least for me, to rewrite it as follows. E and natural log are inverses of each other. So we can write this as e to the power of the natural log of x to the power of cos y. And we can do the same thing with this one. We can write this as e to the power of the natural log of y to the power of x. And that's all equal to 2. But to be comfortable with that, I have to make sure that I'm not taking the log of a negative number. And that's where these two conditions are important. Since x is strictly positive, we know that x to the power of anything is going to be positive. So we don't really care about the sign of cos y. We're quite happy that that can be a negative number, and x to the cos y will still be positive, which means that the log of that is defined. We can go through a similar thought process over here, where we look at the natural log of y to the power of x. So y is greater than 0, so y to the power of x is greater than 0. Now, this is going to help us a lot, because I can now use my log rules to simplify things and then use implicit differentiation. So pause the video here and see how far you can get through to finding dy by dx. I'm going to go through it very, very slowly. So as usual, if it's too slow for you, just skip ahead. Okay, so just rewriting. Now applying my power rules, this is what we end up with. And this is where the simplification starts to kick in. So we've got e to the x log of y, and that equals 2. So I'm going to differentiate term by term. I like this because I know that when I differentiate e to the power of x, I just get e to the x. So the only tricky bit in here is going to be the chain rule part, where I differentiate that function, and that's where I'll use implicit. So now, the first term will give me e to the cos y ln x times the derivative of this with respect to x. So using the product rule, it's going to be the first function, cos of y, times 1 over x plus negative sine y dy by dx. So that's implicit on cos of y times the log of x. That's that bit done. Now moving on to this, plus e to the x ln y. Right, implicit differentiation, product rule and implicit here. X times 1 over y dy by dx plus 1 from here times the natural log of y equals 0. Now I've just got room to squeeze in the cleaning up part. here we've got x to the power of cos y times 1 over x cos y minus x to the cos y sin y log x dy by dx. Two more terms to go, plus y to the x times 1 over y. Goes on forever, but we are getting somewhere, dy by dx, plus y to the x log y equals 0. Now we've still got a bit of tidying up work to do here. We need to collect up the terms with dy by dx, and you can see that here we've got a 1 over x here and an x cos y. So pause the video again and just go through and tidy up a little bit first before you get an expression for dy by dx. I'm going to do that on the next slide. Okay, so you should end up with this, x to the cos y minus 1 cos y plus y to the x ln y is equal to dy by dx sin y log x times x to the cos y. Now we should probably put some brackets around there. Minus y to the x minus 1 times x. So in the end, this is my answer for dy by dx. Alright, so there you go. So once we're back at school, if you're in my A-level class, then we will have a wee look at that function in Desmos or GeoGebra and just have a play around with what the slope of the curve looks like. So it's a pretty unpleasant derivative, but hopefully that trick of using e to the power of x to simplify log problems is one that you can reuse in other questions.